Hi, I'm Kathy Manley. This video covers Lesson 4, Hello World from Course E. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in this lesson, to model pedagogical strategies for implementing the lesson, and to review computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies addressed in the lesson. There are 3 lessons that we've asked you to do with your students this fall. The first one was Lesson 3, Swimming Fish with Sprite Lab. This Lesson 4, Hello World, and Lesson 6, Drawing Loops. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence and events as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. In this lesson, we will focus on decomposition, algorithm, and debugging. Students will use additional critical thinking skills such as compare and contrast, cause and effect, predict, problem solving, plan, and observe. In this video, I'll demonstrate this lesson and point out opportunities to use these pedagogical strategies to support student learning. We will use student-centered learning, where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach, where students predict, run, investigate, modify, and make a program. Lastly, we will focus on the process of problem solving. Lesson 4 also begins with a video, which is Hello World. The video explains the parts of the screen, the play space, the toolbox, and the workspace. It also explains how to build programs, algorithms used by a machine, and how to change a sprite's costume and location. This video introduces a new block called the Say block. Go ahead and have students move on to open up their programs and move to Lesson 2. In Lessons 2 through 5, prediction and observation will be important. Have students slow down and focus on problem solving by determining the problem they are asked to solve, make a plan, and then put their plan into code. Another key concept to discuss is debugging when the program doesn't perform as they predicted. This puzzle introduces the Say block. Often what will happen is they will move this over and forget to change the sprite. So one thing, maybe encourage them from this point to start changing the sprite. I'm going to change mine to a hamburger, and I'm going to make a sprite, and then I'm going to make the hamburger say Hello World. And when they're ready, they're going to click run, and they should notice that the hamburger has Hello World above it. In puzzle 3, students are going to work on changing location. So it might be hard to see, but there's both carrot and broccoli in this image. And so what we want to do is move one or both of those to a new location. So the students will click on the pin and drag this other sprite to wherever it is that they would like it to be located. They'll drag the sprite to wherever they want to locate that new sprite. When they click on run, nothing will change because all they've done is make a sprite and select its location. So it's important for them to also kind of make that prediction that they won't see anything different when they click run. In puzzle 4, we're going to add the Say block to both of our sprites. So we've already made broccoli and we've made the carrot. And so what we're going to do is drag the Say block over here so that the broccoli says hello carrot. Well, we want the carrot to say hello back. So we're going to drag another one, but notice that it still has broccoli as the costume. So we do need to change the costume to carrot. And I want to change the words here. So it's not saying hello carrot, it's saying hello broccoli. It's important, again, have them make a prediction as to what they think will happen here. When they click run, both sprites are made and both sprites will say hello to each other. When we move to puzzle 5, it's important to kind of have students slow down here. When you pull this up, it's really tempting for them to immediately click on run, but we want them to really make some observations here. It's a good point of discussion. So it introduces events. In this case, we want them to first kind of make a prediction. They should notice a couple of things. They should notice that these green blocks are not connected to the rest of the code. These are the event blocks. They'll also notice that it says when the cupcake is clicked. So now we're going to have some interaction. And when the cupcake is clicked, it should say sweet. So when you click on the ice cream, you should have this where it's going to say cool. So let's run it and take a look. When I click on the cupcake, it says sweet. When I click on the ice cream, it would say cool. The puzzle is introducing events, which will be covered in the next video. When you click on the ice cream, it says sweet, and events are something that happens that causes something else to happen. And they're really important. They're used to make interactive media. When you click on the cone, it will say cool, which is another event. It's also another good opportunity to talk about cause and effect. So you'll move on to the video. This video will introduce that idea of programming with events. So discuss cause and effect. With those events, the cause was listening for a mouse click, an arrow button press, or a tap on the screen. An effect was the reaction, running a code such as saying hello world. Events have their own algorithms. That's why they're not attached to that original code. Other thing you can do with this video, now that we're talking about events, is discuss connections to popular games and apps. What kind of events do they see in those games and apps? Students will then move on to practice with these skills. In puzzles 7 through 12, they're going to add events and behaviors for their sprites. It's a good time to review problem solving, including that idea of decomposing or breaking down those tasks. When they know what the problem is they're trying to solve, what are the steps they need to take to get there? And the PRIM approach, predict, run, investigate, modify, and make. So in puzzle 7, they're adding an event for a sprite. So the problem here that they want to ask themselves, what's the problem? I want to make my sprite say something. Well, part of that planning is, what do I want my sprite to say? I want mine to say, what's up, friend? So what steps do I need? We're going to decompose and think about the steps it's going to take for that to happen. What blocks will I use to do this? And remember that we want them to predict what they think is going to happen when they click run. That's going to help them really think about what blocks they need and think about the cause and effect that they're going to see. Again, that will help them really think. So my cause and effect is when I click on the hamburger, I want it to say, what's up, friend? And the what's up, friend being printed on the screen would be the effect of clicking on the hamburger. So I'm going to drag my when clicked. When I click on the hamburger, I want the hamburger to say, what's up, friend? If I did it right, then when I click on the hamburger, it should say, what's up, friend? In puzzle 8, they're going to use the event in a new way. In this one, when they click on the taco, we want the background to change. And we're going to change it to this blue. So I already have the when clicked. All I need to do is drag the background. The prediction should be that when I click on the taco, the whole background should change. I'm going to test my prediction. It worked as I expected. Again, we can talk about cause and effect. When they move on to puzzle 9, they're going to again use an event. This time they're going to use the event to change the costume. So when I click on the cupcake, I want the cupcake to turn into a cake. So I'm going to test this. When I click on the cupcake, it turns into a cake. And then the last one that we're going to go over with you right now is puzzle 10. They're going to again use the event, and this time to change the size. So in this one, there are blocks here to set the size and change the size. We want them to change the size. So when I click on the banana, I wanted to change the size. Have them predict what's going to happen. And it's interesting because the more you click, the more it changes the size. So kind of see if you can get them to get to that prediction. I'm going to change the size a little bit to make it a little more dramatic. When I click run, each time I click on the banana, it gets larger. Puzzles 11 and 12, students will continue to review behaviors that they've done before. And when they're done with all of these puzzles, really talk about that compare and contrast between behaviors and events. Now that we've created these events, what happens when I click on run? With a behavior, it runs automatically. With events, I need to have another cause and effect where I click on the object and then there's an effect. So you can both review, compare and contrast, and cause and effect. You can also talk about how sequencing impacts behaviors and events, because in the events, the sequence in which you create them doesn't matter. It's the user that creates that sequence. And then in puzzles 13 and 14, they're going to have some free play. So before you get there, that might be a really good time to wrap up what they've learned, to talk about those problem solving and critical thinking skills they've used to reinforce this idea of debugging, and then have them watch the video for puzzle 13 and do some free play, think, and code in puzzle 14. For teachers, there is one additional thing that you might want to take a look at in the lesson plan. In the lesson plan for Hello World, there are computer science connections at the bottom of the lesson plan. Those will take you to some possibilities for ELA connections that you can make, as well as science. One of the ones I want to take a look at with you really quickly is ecosystems, a science connection. When you click on the ecosystems, you get a whole lesson plan with links, tutorials, as well as how to use the PRIM model to have the students develop their own ecosystem and have the interactions within that ecosystem. You also have the standards and vocabulary to use and some other ways to adapt the project. Okay, let's take a moment to debrief. We covered several computational thinking concepts and powerful ideas that align with this lesson. We talked about sequencing. Students needed to create a sprite before they could assign a behavior or add an event to the sprite. Students then created events which caused something else to happen and make interactive media. They could create events in any order. The sequence of the events was then determined by the user. Students used decomposition whenever they considered the problem or goal for their problem, planned the steps, decomposed those steps, and developed their algorithm. And when clicking run or clicking on a sprite and it didn't accomplish their intended goal, students needed to debug the problem. We also applied critical thinking skills by having students compare and contrast the written steps in computer code, observe cause and effect of click and run, make predictions, solve problems, make a plan, and observe the code. We also employed a variety of pedagogical strategies by encouraging students to play, think, and code while providing direct instruction for key elements. Students also focused on understanding the problems, devising solutions, and using the PRIM approach to investigate and make their programs. When you're working with students, it can be helpful to reinforce this vocabulary, especially in other classroom activities, to reinforce the skills they're learning. And we encourage you to address additional computational thinking concepts and powerful ideas when the opportunity arises. Thank you for watching this video.